class, today we're going to be covering section 3.2, which is all about graphs of linear equations in 3 variables. So remember that when I have a linear equation in 2 variables, the solution is the set of ordered pairs on the line. So 5x plus y equals 10 has a solution 1, 5, but really its solution is every ordered pair on the line 5x plus y equals 10. When I'm working with a linear equation in 3 variables, this is a little bit different. Their solution is all the ordered triples on the plane. So the graph in 3 variables forms a plane, kind of like a sheet of paper. I tried to include a good image over here, but it has a solution 1, 1, 3. When I'm working with linear equations in 3 variables, this system is going to give me 3 equations. And there are 4 different types of solutions that I can have. The first is that the 3 planes represented by each of the equations meet at a single point. They can intersect at a line. The 3 planes are the same, so then we have infinitely many solutions. Or the 3 planes have no points in common between all 3 of them, and that would be no solutions. Here's a visual representation of the 4 different types of solutions that we can have. Like I said, they could intersect in a point, they could intersect in a line, they could have all points in common, so that's the solution would be all the ordered triples defined by this plane. They could be parallel planes, so there's no points in common, or only a couple could intersect. So there's lots of different ways for that to happen. So when we're solving a system of 3 equations, what we want to do is select our focus variable. This is the variable we're going to be eliminating first. Typically, you want to pick a focus variable with a coefficient of 1 or -1. And our working equation will be the equation that contains our focus variable. Next, we're going to eliminate that variable using our working equation and one of the other 2 equations. What this will give us is a 2-variable equation, and we know how to work with 2-variable equations. Step 3 is we're going to eliminate the focus variable again using the working equation and the remaining equation. Next, we're going to take our 2-variable equations and solve that system using substitution or elimination. It's up to you. Then we want to find the remaining variables and check our solution. So let's work through an example. I have 4x plus 8y plus z equals 2, x plus 7y minus 3z equals -14, and 2x minus 3y plus 2z equals 3. I'm going to go ahead and pick our first equation to be our working equation, and our focus variable to be z. Let's switch to a prettier color, shall we? So the first thing I'm going to do is I'm going to take my focus equation, which is 4x plus 8y plus z equals 2, and let's go ahead and work with our second equation. So I have x plus 7y minus 3z equals -14, and we want to eliminate z using elimination. So what would I need to multiply this first equation by in order to have our z's cancel out when I add it to my second equation? Well, we're going to have to multiply by 3. This gives me 12x plus 24y plus 3z equals 6, and I can go ahead and add that to my second equation. When I do that, I'm going to get 13x plus 31y equals -8 because my z's cancel out. So this was step 2. Step 3, I'm going to do step 2 all over again. I take my focus equation, my working equation, and I take 2x minus 3y plus 2z equals 3. Now, what would I multiply my working equation by in order to cancel out 2z? Well, I'm going to multiply it by -2. This gives me negative 8x minus 16y minus 2z equals negative 4, and 2x minus 3y plus 2z equals 3. I'm going to go ahead and add it together. So negative 8x and 2x gives me negative 6x. Negative 16x and negative 3x give me negative 19y. My z's cancel, and I'm left with negative 1. Now I have two equations in two variables, and I can go ahead and solve these. So step 4, I have 13x plus 31y equals negative 18, and negative 6x minus 19y equals negative 1. In order to eliminate my x variable, I'm going to have to multiply this top equation by 6 and this bottom equation by 13 in order to have the smallest number possible that would allow my x's to cancel out. So I have 78x plus 186y equals negative 48, and negative 78x minus 247y equals negative 13. I add those together and I get that negative 61y equals negative 61. So y equals 1. Awesome, I have found one of our values. Next, we're going to go into step 5, which is finding the remaining values. So let me clear myself a little room. So for step 5, I'm going to substitute y equals 1 back into either of these linear equations. It doesn't matter. Let's go with negative 6x minus 19y equals negative 1. So I have negative 6x minus 19 times 1 equals negative 1. I then have negative 6x minus 19 equals negative 1. I add 20 to both sides. So I add 19 to both sides. That gives me negative 6x equals 18. So I get that if I divide both sides by negative 6, I find that x equals 3. Now I have two parts of my ordered triple. I have when x is 3 and y is 1. And I'm going to go ahead and now I can solve for y. So this is 5 part 2. Oh, sorry, I can solve for z. So if I have 4x plus 8y plus z equals 2, that means I have 4 times negative 3, because that's a negative 3, plus 8 times 1 plus z equals 2. So I have negative 12 plus 8 plus z equals 2. I get negative 4 plus z equals 2, so z is going to give us a positive 6. So here's my ordered triple, and we would check our solution by substituting it into each of our 3 equations. Let's work through a few more examples. So in this next set of 3 equations, system of 3 equations, I have 4x plus 7y equals 27, 8x minus 3z equals 55, and 6y minus 3z equals negative 21. It's important for us to note that we are still working with 3 planes. It just so happens that the coefficient on z here is 0, the coefficient on y here is 0, and the coefficient on x here is 0. So let's go ahead and pick a focus equation. I'm going to go ahead and take a look and see that, okay, I already have an equation in x and y. So if I can use these 2 equations to eliminate my z, that'd give me an equation in x and y, and then I'd have a system of 2 equations in x and y. So I'm going to take 8x minus 3z equals 55, and 6y minus 3z equals 21. In order to change the sign of the coefficient, I'm going to multiply this first equation by negative 1 on both sides. So I get negative 8x plus 3z equals negative 55. And I go ahead and add that to 6y minus 3z equals 21. Now it's important to remember that I'm adding x and y, so I have negative 8x plus 6y. I cannot add the coefficients on those. Sometimes it helps to write them a little more spaced out so we can make sure that each variable has its own column. So I have negative 55 plus 21 gives me a negative 34. So now I have two equations in two variables. So I have negative 8x plus 6y equals negative 34, and 4x plus 7y equals 27. I'm going to multiply this by 2. That gives me negative 8x plus 6y equals negative 34, and a positive 8x plus 14y equals 54. If I go ahead and add these together, I get that 20y equals 20. So I find that y equals 1. I can then substitute that back in to my original equation. 4x plus 7 times 1 equals 27. I get 4x equals 20, so x equals 5. So I got the first part of my ordered triple. Now I just have to solve for z. So I have that 6y minus 3z is 21. So I'm going to go 6 times 1 minus 3z is 21. 21 minus 6, negative 3z is 15. Z equals negative 5. So here is our ordered triple. This next example, I have 2x minus 4y plus 6 equals 5, negative x plus 3y minus 2z equals negative 1, and x minus 2z plus 3z equals 1. I'm going to go ahead and add these two equations together. And I get that y plus z equals 0, so we're going to focus on eliminating our x. I then need to eliminate x from this equation, so I'm going to take 2x minus 4y plus 6z equals 5. Here's our working equation. So I have negative x plus 3y minus 2z equals negative 1. I can multiply this by negative 2. I get that 2x minus 4y plus 6z equals 5. And negative 2x plus 6y minus 4z equals negative 1. So I get 4 equals 2y plus 2z. Now I need to eliminate one of my variables from this system of two equations. Let's focus on y. So multiply this top equation by negative 2. That gives me negative 2y minus 2 times z equals 0. And if I add that to 2y plus 2z equals 4, I get that 0 equals 4. And this is not a true statement, right? So that means there are no solutions. It means that these equations are parallel and do not intersect. It doesn't necessarily mean they're parallel. What it means is the planes do not intersect.